Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. We are discussing the subject called Data Structures 2, Advanced Data Structures, and in the last lecture we have started discussing the topic called M-way insertion. As we have discussed in the previous lecture, M-way trees are actually let's say an extension of your binary search trees. So in binary search trees, we have a constraint or we have a limitation that the maximum number of children a particular node can have is limited only to number two, or only limited to two. Now in M-way trees, we have removed that particular limitation that the maximum number of children could be any number, but that number must not extend the degree of that particular, let's say, what can I say, the degree of that particular tree. So the in the M-way tree, the M is an integer actually, which specifies the degree of the tree. So this degree is actually specifies that the maximum number of children a particular node can have in that particular tree. So if we have a 10-way tree, in that case, a particular node can have maximum number of children equal to 10. And in association with this, the maximum number of values that we have actually mentioned as or referred to as keys in a particular node in a m-way tree is actually m minus 1. So for example, if we have a 10-way tree, the number of children that particular or any node in that particular tree could be 10, and the number of values, that is keys, in that particular node is equal to 10 minus 1, that is 9. That is the maximum number of value. It could have been less than 9, it could be equal to 0. In that case there will be no node. So it can range from 1 to 9, but not, it cannot exceed 9. So the total number of keys in a particular node in a 10-way tree is equal to 9, and total number of children, or the not total but let's say maximum number of children it can possess, or a particular node possess in a 10-way tree, is equal to 10. So this is a brief recap. So this is a brief recap about what an M-way tree is. Today we are going to see the M-way insertion, that is how to insert a particular node in an M-way tree. So getting back to the I'm getting back to the slides that we have left yesterday, and today we are going to see how to add a particular node in this tree. Okay, so it's going to be a short video. We're not going to discuss much, and in the next lecture we are going to see how to delete a particular node, and after that we're going to see the last topic of this unit, that is your B trees, that is your balanced M-way trees. Okay, so how to add a particular, let's say, node. So let us suppose we want to add, let me get back to you in the next. So this is how we can search a particular node. Okay, we have already discussed how to search a particular node in your M-way tree. So for searching, first you have to compare the value to be searched with all the keys in a particular node. And if you have found that particular key in the list of that particular node, of list of keys of that particular node, then it is okay, well and good. That means we have found the value we are looking for, and if it is not, then either we have to go towards the left hand side or to the right hand side. That depends the actual value of the actual value of the key that we want to find out, and we have to compare that particular value with each subsequent key in a particular node. So if we have to find out or we have to search for 77, so first we have to compare 77 with each of these values until we have found a perfect match, or we have found the range. The range, by range I means that 77 lies between 76 and 198. Now that we have discovered the range of that the range in between which our value may lie, may not lie. Okay, then we have to decide, or now according to the rules we have decided to which pointer we have to look out for. Now as 77 is actually greater than 76, then either we can move to the immediate right pointer of 76, or we can say that as 77 is actually less than 198, we can say we can move towards the immediate left hand side, let's say pointer of 198. So this pointer is actually pointing us towards a whole new different node. And then again, we'll repeat this. We'll repeat the same procedure. That is, we have to compare with each of the keys that are situated in this particular node. And if we have found the key value that we are actually looking for, then it is well and good. Our search algorithm will return that particular value. And if it is not, then again we have to look out for the pointer, the right pointer, which may lead us to the exact location of the value that we are actually looking for. Now we are going to look how to add a particular node or a particular key in a particular node. Okay, now this is a little different what we have studied in the BST. In BST, by adding a particular value means we are actually adding a particular node because we have only one value in a particular node. Now in this case, we have multiple values in a single node. So either we have to look for a new node if our node is already full, remind you that as in this case, if we have to add one value with regard to this particular node, we cannot do that because our tree is actually five-way tree, and the maximum number of keys a particular node can withhold in a five-way tree is actually four. It means that this node is already full, so we have to look around for options. As we have no options downwards, so what we have to do is we have to create new node which can possess up to four keys. But at this point of our time, it is going to possess only one value, that is one key and two pointers, and those two pointers will be null pointers. As this particular node is going to be your, let's say, is going to be your leaf node now. Okay, so I think we have got the idea how we are going to do that. So let's take an example how to insert. Uh, so to insert a new element into an M-way tree or search tree, we proceed in the same way as we have in order to search for the element. That is, first we have to look out for the element. So let me take one example. Let me see if we have the same example or not. Yeah. So let's try to add six. Okay. So what we can do is we can have this picture and copy it and paste it on the pane so you can have better illustration of what we are actually talking about. And there it is, yeah. So now we can take the help of pen. So now we want to actually let's say use or add six. Okay, so write six here. Please pardon my writing, I'm using the touchpad of my laptop. It's damn difficult to write. Okay, so in the first step, all we have to do is just use our search algorithm. So in the first step, we have to look inside the root node if six is there or not. So how we'll proceed? We'll proceed with the first key, that is 18. Now in the very first key, it has been found out that the value that we are actually looking for to insert in the tree is actually less than the very first key value. The very first key value in the root node. In that case, according to the rules of your M-way trees, the either it is or the either we can add that particular value in the root pointed out by the immediate left pointer of 18, that is this. If this pointer is actually pointing to some node, in that case you can add that particular 6 in that particular subtree, or if this is a null pointer, then we can create new node. Now fortunately, this pointer is actually pointing to some other node. Now we have reached to this node. Okay, so there is no need to look further in this particular node because the very first key is actually greater than the value that we want to add. In that case, our search inside this particular node is over. So we'll proceed to the immediate left hand side pointer of the value 18, that is the very first key, and we have reached uh, at this place. Now, as you can see, that we again will repeat the same procedure. That is, we will again compare the value 6 with all the keys in this particular node, and we will actually try to find out if this the actual place where we can insert this value 6. Now we'll compare 6 with value 7, and it has been found out that we'll find out that the value which we are going to add, that is 6, is actually less than 7. That is the first key of this particular node. Now we don't have to look towards the immediate left hand side pointer. Why? Because you can see that in this particular node, the immediate left hand side pointer of 7 is null first, and second, the capacity to hold keys in this particular node is not over. That is, it can still hold two more keys. That is, it can still hold two more keys. As we have know that in a five-way tree, the maximum number of keys a particular node can accommodate is actually 4. Now we have only two keys here, and instead of creating a new node, as you know that 6, if we have to, if this would have been binary search tree, in that case 6 would have been come down towards the left hand side of the 7, but in that case we can actually accommodate 6, and this 6 will actually come here in this place. So 6 will be added at this place, and we will have one more pointer, and this will actually also, let's see, we pointed at the rate, this will actually be null. This is a null, please don't get confused, this is also a null. So 6 has been created, so let me put it in a box. So 6 has been created here. Now why we have inserted 6 in this particular node? Because the capacity of this node is not over yet. Still we can add one more key value, key pointer value here, key pointer pair here. So this is how you insert. And if, let's suppose this particular node here is full, like in this root case, in that case we have to again come down and create a new node. So I think you have got the idea how we are going to insert a particular value in your MV tree. So what we have to do is we have to look, or we have to find out the exact pointer place in which we can either lead towards the to the downward, to the downwards value, downward subtree. If the downward pointer, or the pointer in which our number or our key can be added, is null, then we have to first look if the capacity of that particular node is full or not. If the capacity of full, in that case we have to create a new node. If the capacity is not full, then in that case all we have to do is we have to add a key, and that key is going to be the value that we are actually trying to insert, and that the place of that insertion in between the keys should be actually that all the terms, all the keys towards the left hand side of the place where it is been inserted is less than the value. That is, all the keys that is towards the left hand side are actually less than 6, and all the keys towards the right hand side is actually greater than 6. So we have to add, uh, let's say 8. Well, 8 is already there. Let's say if I don't want to add 8, okay, if 8 is not there in a, you can say, in that case what we have to do is either way you have to come down if this particular row is not null, or you can add your 8 in between 7 and 12. So this is how it goes. So I think you have got the pretty good idea how we can add a particular value in your MV tree. And in the next lecture we're going to see the deletion from MV tree. Thank you.